Now we come to our third example. We look at a binary symmetric source and some erasure distortion. We again look at a binary symmetric source which puts out 0 and 1 with equal probability. And as x hat, we have now a bigger alphabet, which includes the 0, the 1, and the delta, where this delta represents an erasure. So the distortion is equal 0 if the two symbols are the same. It's equal 1 if the x hat is equal to delta, and otherwise it's infinity. Of course, we want to achieve a finite distortion. Therefore, we have to choose the probabilities that we receive 1 if 0 is sent, and that receives 0 if 1 is sent, equal to 0, because otherwise we will get infinity distortion. And we have to choose the probability that x hat is equal delta smaller equal d. If we do this, we can estimate the mutual information between x and x hat. Look at this mutual information. Of course, h of x is equal 1, and here we have h of x conditioning on x hat. So if you look at the formula for the conditional entropy, this can be written in this way. We sum over all b in x hat and take the probability concerning x hat of b and look at the entropy of x under the condition that x hat is equal b. But look at the cases if b is 0 or 1, because if we receive 0 or 1, then we know that the sender that in the original sequence there was a 0 or 1, because the probability that 0 is changed to 1 or 1 is changed to 0 is 0. So in this case, the entropy is also 0. The only case in which the entropy is not 0, and in this case it's equal 1, is if x hat is equal delta. Because then we don't know if it was 0 or 1 and it has equal probability. So in this case, the entropy is really 1. So it remains here 1 minus the probability concerning x hat of delta. But this probability, we know it's lesser equal d, so we can even choose it equal d. And so we get this, the mutual information is greater equal 1 minus d. So that's the best rate we can get. And we also can achieve this rate. The idea is very simple. We just look at the output sequence and cut the final d symbols. So we just map the symbols, the first 1 minus d times n symbols to some w. And the rest, the d times n symbols, we just cut off. And we just map it to w and send it to and send them. And the decoder puts out now the reconstruction x hat of n by just the first 1 minus d times n symbols. And at the end, he just puts d times n symbols. So we know that this sequence here have distance at most d from the original sequence. And therefore, with this method, we can simply achieve the rate 1 minus d.